these definitions, I just went ahead and typed them out for you. So here's a lovely picture of a circle. It just is a round, obviously, plane figure whose boundary, the boundary would be like the outside edge, consists of points equidistant from a fixed point, which they call the center. So I'm just going to kind of eyeball and draw in here like the center of the circle. So what they mean by that is if I were to draw a line from that center point to any point on the circle, all those distances would be the same, and that's actually the next definition, which is that this guy is what we call the radius of the circle. Let's put the computers away. We do not need computer right now. Put away. Thank you. All right. Now, and I could draw that anywhere on the circle, just from the center to any point on the circle. That's your radius. Now, your diameter goes all the way across, and it goes through the center. I did not do a good job drawing that, but the diameter goes all the way across, and a diameter, I'm going to write D equals twice the radius. Like a radius on either side of that center point would make up the diameter, so the diameter of any circle is equal to twice the radius of that circle. We're going to use that in a second. And just another definition of semicircle, it's literally just half the circle. So if you go from your diameter, this would be half the circle, this would be the other half of the circle. So this all a semicircle is just half of the circle. So those are the two major things that we're going to use in finding what we call circumference and area this morning. So circumference, this is basically fancy word for the perimeter of your circle, so it's specifically called a circumference for a circle. Does anybody know a formula for how to find the circumference of the circle? Does anybody remember it? There's actually two different formulas you can use. Anybody know? It involves pi. Yes, no, maybe? Okay, if you don't remember, I'm going to write two formulas here. Okay, so circumference, we'll just use like a capital C to represent that. If you know the radius, you can do 2 pi times the radius, or the other formula, which really these are the same, but it just depends on what you're given in the picture, what might be easier to use. The other formula is pi times the diameter. But remember, I just told you up here the diameter is twice the radius, so basically what's being replaced in that little equation is 2r. Instead of that, I put the diameter. So just depending on which one you have in the picture, the one formula might be a little bit faster than the other. The other formula I'm going to give you real quick here is the area of a circle. And for area, we're just going to represent that with the capital A. And we just got done doing an entire area unit, so this is kind of an extension of that. Area of a circle is pi times your radius squared. And there's only one formula for that one. You've got to know the radius of a circle to be able to find the area. Okay, so we're just going to practice these two things real quick. And I'm going to have you write them in two different formats because some of the questions are going to ask you to leave the answer in terms of pi. This is kind of like leaving it in radical form and then rounded to the nearest tenth. So I'll show you where the buttons are on the calculator. All right, so here's my circumference. This gives me 12 feet. And what is that 12 feet representing in the lovely picture? Radius, right? Okay, so if I have the radius, I would probably use the little formula, the 2 pi times the radius, because I know the radius. All right, so if you want to leave this in terms of pi, literally all we're going to do is take 2 times that radius and just write the pi next to it. So 2 times 12 is 24, and then you just, that's in terms of pi. You just leave the pi right next to it. And in terms of a label here, it would just match whatever the dimensions are in the problem. We're just in one dimension here, so this would just be 24 feet. I'm sorry, 24 pi feet. Now, to write in terms of pi, if you guys are borrowing one of my calculators, then I'll show you where the pi button is real quick. I would type 24, and then you have to hit second, and then there's a little key above the division sign, which is where the pi value is at. Sorry. So we're going to hit second, and then it's a little caret to do an exponent, but the second function on that is pi, and then you just hit enter, and it'll go ahead and give it to you. If you guys have one of these calculators, 24, and then your pi button is the fourth button down on this left side, and if anybody has a different calculator, then you hit enter. If anybody has a different calculator and you can't find your pi button very well, I will be happy to come over and look at your calculator to figure out where it's from. But to the nearest tenth, we're just going to go one decimal place. So I go 75.39 would round that up to the nearest tenth. This is going to be 75.4. It's still in feet. It's just giving the answer in two different ways. A lot of times the in terms of pi doesn't mean a lot to people, but the decimal will mean something a little bit more to you. And the exact answer is when we leave it in terms of pi. So that's why we're going to practice both. All right. What am I giving you in this picture? I've got circle drawn here, and I have 4 meters. Radius or diameter here? Diameter. Okay, so if that's the case, I would probably grab this second formula. Circumference is pi times the diameter. All right, now, literally, all I have to do is put in the 4. Typically, if you write an answer and you have a number and a pi, you put the number in front of the pi like that. So I would say 4 pi. This would be meters in terms of my answer. And then if I want to do that to the nearest tenth, just so we can practice this, that's what we call an exact answer in terms of pi. And then if we actually take 4 and multiply it by pi, you don't have to put a multiplication sign in between these. You could just write it right next to it and hit enter, and it should tell you what it is on the lovely calculator. So to the nearest tenth, this would be about 12.6 meters. Is anybody having a question? Okay, now all I'm going to do is have you find area. So it doesn't matter whether they give you the diameter or the circumference, they have to use the same formula. So your area formula, just so you guys can see it, is pi times the radius squared. So if you don't have the radius, you're going to have to figure out what the radius is. So in this one, I'm giving you the diameter, right? The diameter goes all the way across, that's 20. What would the radius be if the diameter is 20? 10. Okay, so you got to make sure you plug in the right number. So if I want to do my area, leaving it in terms of pi just means I'm actually going to write the pi in my lovely answer. So what's 10 squared? I gotta square the radius. Does anybody know what 10 squared is? 100. So in terms of pi, this would just be 100 pi. And since it's area, we are in square units. So I'm just going to call that feet squared. So all I did was square the 10. That's it. 10 times 10 is 100. Now, that's your in terms of pi. To the nearest tenth, just type 100 and put your little pi button. Hit equals, and we're just going to go to the nearest one decimal place. That's what's going to ask you in all these questions. The nearest tenth. So this would be about 314.2 square feet. This is not bad, just make sure you're picking the correct formula. The question right next to this is super nice for us because it just gives us the radius. So the radius right now I can see in the picture is 5. So all I got to do, area pi times my radius squared. What do we get if we square 5? 25. So we got 25 pi here, and this guy would be inches squared. And then all you got to do the nearest tenth, if it asks you for that, is just type that in your calculator. So 25, just hit your pi button. You don't even have to put a multiplication in between them. So this is 78, let's go 0.5 to the nearest. Just one decimal place is what's going to have you round it to. Is anybody having a question? Okay, not horrible, and you guys will be given these formulas on any test or quiz, of course. These questions at the bottom are going to kind of work with those formulas, but it's going to give you the area or give you the circumference and ask you for either the diameter or the radius. So this guy right here says find the diameter of the circle that has the given information. So here A stands for the area. So what I would tell you to do, I'm just literally going to put the area formula in place of the letter A. So this is saying, okay, pi r squared would be equal to the area they give me, which is 16 pi. Now, I know this looks really gross, but it's not too bad. Do you guys see how there's a pi on both sides of that equation? So here's what I'm going to do. I'm going to divide by pi, totally legal, And what it does is it cancels it out on both sides of that equation. So what you're left with is that the radius squared is equal to 16. If the radius squared is 16, does anybody know what the radius would be? Like, how would I get rid of the squared? Oh, everyone's quiet this morning. How do you get rid of a squared? Brody, what do you think? Square root. Okay, what's square root of 16? 4. Okay, now, is this the answer to my question? Because my question wants the diameter. Okay, how would I write, like, what would my diameter be if I know my radius is 4? 8. And that is what I'm looking for as the answer there. So just be careful. If you ever find yourself solving a formula for the area, you're going to be able to find the radius. And if they need the diameter, all you got to do is just multiply it by 2. Now, this question specifically wants me to find the diameter. So with my circumference, I have 2 formulas to pick from. I would pick the formula that involves the diameter, right? Pi times the diameter is your circumference. And then that equals, in this circle, for this example, 162 pi. They're giving me their circumference. I'm just substituting the circumference formula, but specifically with the diameter, because that's what I'm looking for. All I'm going to do, same thing I did on that last question. I'm going to divide by pi, and what it does, it actually cancels it out on both sides, and then you literally don't even have to do anything else. The diameter is 162, and that's your answer. Once you set these up, they're not usually too bad to solve. You just got to make sure you pick the formula for either area or circumference that you think would be best for the question. So this one says find the radius now. So this time we're going to find the radius. So area, I've got pi r squared, I'm just going to sub that in, is 49 pi. Okay, so I'm not going to write it, but the pi would cancel out on both sides if I divide both sides by pi. So I get the radius squared is equal to 49. What would my radius be? Anybody know square root of 49? It's a nice number. 7. Yeah. There's my radius, done. All right, all I did was take a square root there. All right, now this guy's circumference, so make sure you use the circumference formula. So if I'm trying to find the radius, in place of the circumference, I would do the 2 pi r, because 2 pi times the radius will give me that lovely formula. And then we'll just set it equal to what we have. All right, you guys see how there's a pi on both sides, just like the last question. I'm just going to cancel that out, pi on either side. So I'm going to be left with 2 times the radius equals 30. Anybody know what the radius would be there? If I got twice the radius equals 30, what would the radius be? 15, right? Just divide by 2. Radius is going to be 15. And that's it. Is anybody having a question? Okay. Now, the back of this, I think, is going to be kind of new. So, and I'm going to use my highlighters a little bit on this as we go through. We're going to talk about some parts of the circle that I don't know that you would have seen before. I think on the front, we've all done circumference and area before, but this stuff might be totally new to you. So if we have a circle, we're going to deal with it. The entire unit is going to be about kind of having segments within a circle and things like that. And they can form angles, they can form different shapes we're going to talk about as we go through. What I have in the picture here, this guy is a circle, and then I've just got like a radius from P to A, radius from P to B, and that actually forms an angle. And that angle is what we call a central angle. So in this lovely picture here, this would be, oh my gosh, I can't write, angle APB, or you could call it angle BPA. But the requirement for a central angle, if you have it in a circle, the vertex is the center of the circle. So all it is to have a central angle, the vertex is just going to be on the center of the circle. So that's all that's going on there. Okay, now what we call an arc, which is, there's two different categories that those can split into, which we're going to talk about in a second. But an arc is going to be part of the circumference. All right, so it's part of the outside edge. And I've got kind of two arcs I'm going to break this apart into here in a second. But basically an arc, like from A to B here, I'm just going to use my highlighter, that would be an arc, like that piece of the circumference. I also have another arc here. The other arc would be literally like the rest of the circle. And these are the two different kinds of arcs that you can have, which I'm going to jot down here underneath. So in that lovely picture, the one I just wrote, I would call that AB, and basically if you have an arc, it has like a little curve over the top of it. Or that exact same arc, we could call it just like a line segment. You can reverse the order of the letters, A, B, or BA. Both of those describe the same arc. That would be what we call a minor arc, all right? Now, a minor arc, you have two letters for a minor arc, two letters to describe it, just like a line segment. All right, now, when you have this, this measures between 0 and 180. So 100 and, do you guys know how many degrees are in a circle? Like 360. Okay, what's half of a circle? Does anybody know? Half of 360? 180. Okay, so this, if you have a minor arc, basically, actually, let me write a little inequality. It cannot be equal to 0 degrees, and it cannot be equal to 180. So when I say between, it'd have to be like, I don't know, if I had to eyeball that, that looks like it's about, I don't know, 80 degrees in that picture. So it's some measure, it's got to be less than half the circle, but it's got to have some length to it a little bit. So that would be an example of what we call a minor arc. Now, a major arc would be like the other one that I drew there. Major arc, you have to have 3 letters. Now, you use the letters where it starts and stops as the start and stop of the description. So I could call this ACB, or I could call this BCA. So a major arc, you have to have 3 letters to describe that. And if you go more than once around the circle, then you go in the wrong direction. So like if I thought, okay, I'm going to go ACB, like if I trace this, if I start to go this way, ACB, and I end up all the way there, if you go more than once around the circle, you went the wrong way. So ACB correctly should go like this, or BCA should correctly go like this. If I did BC and I went like all the way around and then I had to end up at A, I went more than once around the circle. So that second letter should hopefully tell you which direction to go, but sometimes it can be tricky. Now, in this case, your measures between 180 and 360. So it can't be equal to 180, it can't be equal to 360. So basically I'm going to write 180 is, my arc is going to be between 180 and 360. If you have a semicircle, which we've mentioned on the front, semicircle, I'm just going to make this is equal to 180. So minor arc, major arc, neither one of them are equal to 180. An actual semicircle does equal 180. So we're going to look at this diagram down here. And this can get tricky, and you feel free to draw on whatever you want to draw on. And the semicircle, there's not an actual, you don't have to, you can use 2 or 3 letters to describe a semicircle. Both of those are accepted. So in this diagram down here, if I want to do exactly half the circle, right, I just need to find a diameter. So diameter just goes through the center, connects 2 points on the circle. So example of a semicircle, A to E. That's exactly half the circle. So I could go AE, just like that. The other semicircle, like just go for your diameter from D to C, DC would be a semicircle. Just basically grab a diameter. I usually just use 2 letters if I'm doing a semicircle, but it's exactly half the circle, so you're just looking for a diameter to describe that. Okay, now a minor arc has to be less than halfway around the circle. So like example, AD, right? That's less than half the circle. So I could use AD as an example. I could flip that up and do DA. I could do, let's see, C to E would be less than half of the circle. So just as another example, I have CE. Let's see. I could do AC. That's not half the circle, right? It's a portion of it, but it's not half. So I could do AC or CA. And let me see. I could also do, I'm trying to grab a different color that I haven't used. So D to E. That would also be a minor arc. Minor arc just means that you're less than half the circle. All right. Now, major arc, this is a little trickier. So it has to go at more than halfway around the circle. It says a major arc containing the point A. All right, I'm just going to grab a little thing. So let's say I started at A and I just started going, I have to go more than halfway around. So if I went exactly halfway around, I'd be right there. So I have to go more than that. So I could go to C. Now, as you do the description here, it's completely up to you, but you have to use 3 letters. So I have to start with A, and it ended with C, right? I went from A this way around. You can actually use the letter D or the letter E, either one. So this would describe the same thing as if I did A, E, C. The second letter is just trying to tell you which direction you're going around the circle, as an example. So it's got to go more than halfway around. Now, another way I could draw, let me see if I got a different color I can use. If I started with A and kind of went the other way around, so I have to go at least halfway around. Halfway around is a semicircle. I have to go more than halfway around. So if I'm trying to do another major arc here, I would have to keep going, but I would have another one containing the point A. So I could go from A all the way around there to D. So there would be 2 descriptions for this. So I could go, went from A, I ended at D. You can pick either one of these letters to put in between. So I could do ACD or I could do AED. They actually describe the exact same arc, but major arc just means it goes more than halfway around the circle, but not totally all the way around. Is anybody having a question about major arc and minor arc? Now, this is how we're going to find the measure of an arc, which is what we're going to do in this last question. I promise this is not hard. So, measure of an arc, the measure, if I can spell, is equal to the central angle. So, basically, there's going to be an angle that cuts the arc off. And the central angle and the arc have the exact same measurement. So, we were just talking about like all the way around the circle is 360 degrees, right? So the inside around those central angles is going to match the outside in terms of the arc. So let me just, I'm going to come right here, and I'm going to go back and answer the questions in a second. If this is the central angle, right, the center of that angle is on the center of the circle. If this this angle is 32, then this arc right here that it cuts off, this would also be 32. Okay, now super similar. Let me come over here. So this gives you the arc. It says it's 58. All right, so if the arc is 58, then I'm going to kind of reverse what I just said. If the arc is 58, then the central angle is the same measure, also 58. Okay, so let me ask you a question. Could you guys figure out, here actually let me write this because we just did, measure of arc PQ matches the central angle 32 degrees. The next question asks you for the angle PAS. Anybody know how I could figure out the angle measure here for PAS? It's right here. How could I figure out that, what that angle measures? There's a couple ways you could do it. Exactly. Okay, you guys see there's a diameter. That's exactly half the circle, so that'd be 180, makes a straight line. We're just going to do, we're just going to subtract that 58 from 180. And I'm totally not on the screen, sorry. Maybe, if I can get it. That's all I'm doing. Just makes a straight line. So it's 122. Okay, this angle, 122. That means this arc that it cuts off, that goes from P to S, that exact arc would also be 122. So let me see if I can answer a couple questions here. So PAS, 122. Let's see. Well, I guess they don't ask me for that arc, but that's helpful information. Where is RAQ? How could I figure out this angle? There's a couple ways you could do this at this point. How could I figure out RAQ? It's going to be this angle right here. Perfect. Okay, he says add everything up, subtract it from 360. So I've got all of these. I just don't have this one. So we get rid of the 122, the 32. I don't know why I just put a plus sign. And the 58. Was anybody else thinking about another way to do that? Okay, I'm going to show you this 148, right? Okay, I'm just going to show you this real quick. I could also use that this guy's a diameter, goes right through the center. So the 32 and this angle would have to add up to 180. So the other thing I could do, just do 180 minus 32, and it gives you the exact same answer. So depending on what you got going on in the diagram, you might have some more options to kind of work with as you go through these problems. So I'm just going to kind of extend this out. So this central angle and this arc are going to be the same, which is 148 degrees. So whatever the central angle is, that measurement of the arc outside of the 360 is going to be the same thing. So this is 148. Okay, now each of these is a little bit different. It's not going to match up exactly with the central angle. So this question says find me the minor arc, the measure of that, from S to Q. So here's S. And here's Q over here. How would I find the measure of that arc? I swear you have everything you need in that picture. How would you find from S to Q what the measure of that arc is? Any idea? How would you find S to Q? So S to Q, how would I find that arc? Nobody has an idea? Okay, what numbers did I go around when I did that? You guys see I went through the 122 and the 32, right? S to Q, 122, 32. Literally, all you're going to do, you're just going to add them up. That's it. Just add them together. So 122, 32, add them up. That's the whole thing. That's 154. You just add them together. All right, if I go RSP, now, RSP, here's R, here's S, here's P. What is that's exactly half a circle. So what's half a circle going to add up to? 180. Done. If you got a diameter and it wants the arc that matches that, R to P here, that's going to be 180. Okay, PRS. Now this one's a little bit farther. All right, so here's, I'm going to go kind of this way. Here's P. I'm going to go around to R. And I'm going to end up with S. So like all the way around here. This is a major arc. There's a couple ways you can do this. You could just add, right? We just add those right up. I got the 32, the 148, and I got the 58. Just add them up. The other thing you can do, because this goes almost all the way around the circle, I just didn't use the 122. The other thing you could do, take the whole circle, 360, minus this part we didn't use, which was 122. Give you the same answer either way. It's totally up to you, but this should be 238. All right, PSQ. Here's P, here's S, here's Q. Sorry, I've got not enough highlighters to go around this. All right, so here's P, I'm going to S, keep going around here. This goes all the way to Q, PSQ, all the way around. So I'm starting here, going all the way here. You could add them up or you could subtract the leftover from 360. So from P to S, I got 122. From S to R, I got 58. And from R to Q, where did I go? What was this? PSQ. And then from R to Q, you got 148. Or you could say this goes all the way here. I just don't use the 32. So you could do 360 minus 32, and it gives you the same answer. Just giving you a couple options there. Regardless, it should be 328. Okay, P to R, there you go, that's a semicircle again. Semicircle, just P to R, that's exactly half the circle, so 180. Anytime you have half a circle. A whole circle is 360, half a circle is 180. And then the last one is RSQ. I am trying to see if I have a different color I can use. Here's R to S. And I'm going to end up over here at Q. Sorry, I kind of garbaged this diagram up beyond recognition here. But R to P, that's 180 right there. And then 32 more, we could just add that up. We could do 58 plus 122 plus 32. 212. The other thing you could do, this goes all the way around except for the 148. You could do the whole circle minus the arc you didn't use, which is the 148. It's the same number, 212. So there's multiple ways to do these problems, but the central angle that cuts off the arc should have the same degree measurement as the arc. Is anybody having a question?